go over, don't be shy. I'm going to draw on the screen. Oh, nice one. Okay, so today I want to give you a little bit of discussion of the different regulatory guidance that we are using in our company in the CNQ process. It is all driven by, there is a series of new guidance that came in the recent months and year, the big one being the new next one. There is a revision of the ICHQ9, and what I want to discuss a little bit is that how do you approach those guidance, what is the history, and what is important to remember from those guidance. Right? So, like we do in no deviation, and we have a sticker about it. The first things we put on top of everything we do is the patient, right? And this patient need a product, and that product is made with a process, and that process is made in your facility and with some equipment and some utilities. Right. So what defines the need of the patient will be what we call the quality target product profile, right? And the quality target product profile is really what is the problem you try to solve for your patient. To solve that problem, we're going to give him a product, and that product will answer the need of the patient if we build into it the critical quality attribute. Right? So if my product has the critical quality attribute, then it will answer the need of my patient. So those critical quality attributes are actually built into the product, right? And that is really going from the ICHQ8 that say that you cannot test the quality in your product, you need to build it, and that's what we call the quality by design. The quality by design can be applied to processes, but it can also be applied to the way you design and build any equipment. So that process, we will control it with critical process parameter. And those critical process parameters are things that I can change and control, because if they are within a certain range, I will build the quality in my product, and I will meet my CQA, and if I meet my CQA, I will meet the QTPP. So how do I do that? Well, let's take, for example, a sterilization autoclave. In a sterilization autoclave, one of the critical quality attributes is that the product is sterile. What are the CPP? I have the time and the temperature. So those two process parameters that I can change. And how do I do that? In my autoclave or in my equipment, I will have design elements, and the critical design elements are the ones that allow me to control the CPP. Okay? So those three definitions, you can find them in the ICH Q8, and the CD, you will find it in the ISP new baseline guide on CNQ, right? So you can see that everything that's related to quality, I call them critical. Whether it's a critical quality attribute, there is a critical process parameter and a critical design element. When it's critical, it touches the quality of the product, and when it's critical, I will need to do qualification of those, right? So once I have that, this is why I need to qualify. How do I qualify? How do I define what is critical? I will do a risk-based approach, right? So really the risk-based will be what? How do I know what is critical? So the definition of risk is simply the probability times the severity. Okay, what is the probability of the harm to the patient times the severity, if that happens, how the patient will be affected. And the quality risk management is defined in that ICH Q9, right? ICH Q9 has been on the market for the last 15 years. I think it came in, or maybe 17, it came 2007, 2009 was the period it came, but they came with a new revision this year. And the reason of the ICHQ9 revision 1, it's not to change what we are doing. is to make it better. So one of the main reasons they reviewed the ICHQ9 is because they realize that we're not applying efficiently and effectively quality risk management, right? And so there is another revision that came, or one point that they revised it for, is because we also want to consider that if the patient doesn't get the drug, there is also a risk for the patient, right? And I always take the example, if you are dying from cancer and I come back in 6 months because we have a drug shortage, that's a bigger risk for you, right? So those are the reasons ICHQ9 was revised. This is also the reason why the Annex 1 was revised. So the Annex 1 was a very old document that is talking about sterile manufacturing and aseptic manufacturing. So a lot of people talk about Annex 1. We just want to remember that an annex is to a document. The document the Annex 1 is related to is the Annex Volume 4, which is the European GMP. So that Annex 1, the first revision, I think we talked about 20 times about risk. In the new revision, I think it's more than 150 times, but definitely more than 100 times. So what they try to do in the new Annex 1, a sterile product still need to be sterile, but how do we get there? Will be better explained in the Annex 1, considering the risk to the patient and how you make those decisions, right? And so you will see that in the Annex 1, in the new Annex 1 revision, we try to move away from the grade A area, and we try to embrace innovation, and it's not so much an innovation anymore, but we try to embrace isolator. And why we do that is because the main source of contamination to the product is the people in the room. So if I can remove the people from the room, I eliminate the risk. And if I eliminate the risk, it's the best way to do a risk mitigation, right? So really pushing people more and more outside the room, moving from a grade A area where I'm literally above the product and what do I do if I sneeze, to a rough sub-area where I was putting a physical barrier so that I can have only a limited interaction above the product, to putting a glass door and a container so I can achieve that zero growth grade A area within the isolator. And as Shanshan have explained last year, ideally we put a robot instead of a human so that I can automate it and I remove a lot of variability, because source of variability are also a source of probability of risk, right? And as you know, the operator is supposed to follow the procedure, but operators don't always follow the procedure. So if everything I can automate, I will really work on that probability, right? Because the severity, a non-sterile product will always be harming the patient. So us as engineers, our role is really to try to reduce the probability. And this is why Annex 1 is coming out. This is why there is a revision of ICHQ9, right? The vision is still the same, which is to protect the patient. How do we get there is try to be better implement, and the regulatory will be looking at the risk-based approach. There is another new term that came in the Annex 1, which is your contamination control strategy. And the contamination control strategy is an overarching document from the raw material to the finished product to the QC to your equipment to your operator. Where is the contamination coming from? And how can you reduce that contamination? How can you reduce that probability of occurrence? How can I reduce the risk of contaminating my products? So again, the contamination control strategy is just one way to express the fact that you need to make a risk assessment and mitigation not to contaminate the product. The contamination control strategy is a new term, but in sterile product, simply your sterility assurance. And a lot of people get scared when they hear contamination control strategy, but a lot of companies already have a sterility assurance program in place, right? So the Annex 1 is renaming it, right? And it doesn't only talk about sterility, but obviously sterility assurance is a subset of your contamination control strategy. So if you need to write that new document, you already generally have a good basis to start with your sterility assurance program. So that is how ICHQ9 can help you to apply the new Annex 1 and can help you to build the quality into your product, because you can't really test sterility. Okay? The product you give to the patient was never tested, and the product you test was never given to the patient. Okay? And so that's why the risk-based approach is important, and this is also why we do process validation. So that's in a nutshell how basically ICHQ8 and ICHQ9 help you to apply the new Annex 1. And then you have the ICHQ10, which is your pharmaceutical quality system, that makes sure that when you are in operation, you remain in control of your operation. Right? A lot of those contamination control strategies, a lot of those risk assessments are a plan. And when you make a plan, you need to check if your plan is working. So what ICHQ10 is doing is to force you to do that PDCA to make sure that what you thought was a good idea is indeed a good idea. Right? And doing that periodic review and reviewing any incidents, because maybe you thought it was a low probability, but your CAPA will show you that it's a higher probability, and therefore your mitigation needs to be more stringent. So if you want to know more, I'll be here for the 2 days. We have a lot of talk about that, and you can approach any of us. Thank you.